everyone, my name is Fiona.
And my name is Michelle.
And we're so excited to show you just how cool the water cycle can be with something so cool that it wouldn't even exist here on Earth without the help of very talented scientists.
First, let's review just how unique water is on its own. Water molecules are bipolar, meaning one side of the molecule is more negatively charged while the other is more positively charged. This is why water is so good at dissolving things. Water is also the only naturally occurring substance on Earth that can be found in 3 physical states: solid, liquid, and gas.
Water vapor is all around us and forms humidity in the air. When it gets cold, it condenses back into droplets we can see, which forms clouds in the sky and fog on the ground.
Liquid water covers around 71% of Earth's surface, and about 96.5% of that water is salty.
You might find solid water or ice accumulating inside your freezer, floating in your lemonade, or falling from the sky in the form of snow. Water is less dense in its solid form than it is in its liquid form, which is another interesting property of H2O.
Since snow is just solid water, it's an important part of the water cycle. Snow is a form of precipitation, or water that comes down from the clouds.
Because it takes a while for the water to undergo the complete water cycle, we're going to speed things up by cooling things down with some liquid nitrogen.
Since we just covered precipitation, let's jump to evaporation next. This is when standing water is converted into water vapor through heat energy from the sun, just like how liquid nitrogen turns into nitrogen gas when exposed to the room temperature air.
When the evaporated water vapor rises high into the atmosphere, it cools down and forms tiny water droplets through the process of condensation.
That's a good recap of some of the major parts of the water cycle. But remember when I said that more than 95% of all of Earth's water is salt water? I wonder if that impacts the water cycle at all.
Salt water and fresh water will undergo the same steps of the water cycle, but salt affects the timing. For example, watch how these 2 beakers of water freeze at different rates. The one on the left is fresh water, and the one on the right is salt water, around 20% salinity, which is the average across the Great Salt Lake. Liquid nitrogen is extremely cold, about negative 321 degrees Fahrenheit, so it easily freezes the fresh water at 32 degrees. However, the presence of salt prevents water molecules from organizing into a solid ice structure effectively, lowering the salt water's freezing point to around 28 degrees. This impacts the Great Salt Lake's ecosystem by keeping the lake liquid all year round.
Clearly, there's a difference in freezing points between saltwater and freshwater. But do you think there's a difference in boiling points? How might saltwater and freshwater evaporate differently? What do you think they might leave behind? Now it's your turn to investigate and make your own discoveries.
Thanks for watching!